In this lecture, I will discuss about working drawing. The drawings which are needed for the construction of any object or building anything, what type of drawings are needed, that are called working drawings. Topics that I will cover: introduction, detailed drawing, assembly drawing. Introduction. Definition: working drawing is a set of drawings used during the work of making a product. Working drawing include detail of drawing, assembly drawing. Assembly drawing is the addition of drawing. So in some parts of the piece or the object, assembly drawing is needed. In the detailed drawing that we have discussed in the previous lectures, like orthographic drawing, section drawing, pictorial drawing, all drawings are included in the detailed drawing. Second one, in the assembly drawing, in the working drawing, that is assembly drawing, that I will discuss in this lecture. Detailed drawing is a multi-view representation of a single part with dimension and knots. Assembly drawing is a drawing of various parts of machines or structure assembled in the relative working positions. When I will explain, show the picture of assembly drawing, then this definition will be clear. Then the multiple parts of the machine are shown in the one drawing with their relative positions. Detailed drawing conveys the information and instructions for manufacturing the part. Assembly drawing conveys completed shape of the product, overall dimensions, relative position of each part. Functional relationship among various components. Detailed drawing. Information in detailed drawing: journal information, title block, parts information, shape description, size description, objects views like top view, front view, right side view. Specifications in terms of notes, like what is the material, what is the strength of the material, so just like that. In journal information: name of company, title of drawing, drawing sheet number, name of drafter or checker, relevant dates of action, drawn, checked by, approved by, on which dates, revision table for the revision of drawing. If there is any change in drawing, then drawings are revised, so then that revision table. Unit, scale, method of projection is mentioned on the drawing. Parts information. Shape, we got the idea for the parts information, like with the orthographic drawing, top view, front view and side view. If necessary, then we can give the 3D drawing, pictorial drawing and the section views. Size, dimensions and tolerances. Tolerance is, for example, there is a 10 millimeter or a dimension of any part. So there is maybe tolerance that 10 millimeter plus minus 1 millimeter means that size of the object can be increased or decreased with the 1 millimeter, then there will be no issue. So that is called tolerances. Specifications: part number, name, number required, etc. Type of material used, journal notes, surface finish are mentioned in the specifications. And the tolerances I have already explained, the general tolerances. Recommended practice: drawn all parts using the same scale, otherwise the scale should be clearly not under each part's drawing. Means all the drawing should be on the one scale, and if there is some part have different scale, means that is enlarged or reduced the image, so then that is should be mentioned under that part of the drawing where there is enlargement or reduction is done due to scale. Here is a placing an information in this course. We will whenever we draw any drawing, completed dimensions, orthographic drawing, part number, part name, material, knots, unit, fillets, round sizes, etc. And on the bottom side there will be title block. Here, interpreting detailed drawing, that is a orthographic drawing, top view and right side view. Here, that is the orthographic drawing, orthographic views, dimensions and the tolerances. Here you are seeing the tolerance plus minus 0.02. Okay, surface finish, journal note, title block, revision table, journal tolerance, projection method, orthographic projection. Assembly drawing. Types of assembly drawing: exploded assembly drawing and journal assembly drawing, and the third one is the detailed assembly drawing. I will again come back on these three types. First of all, just see what is assembly drawing. Here is a finished product, so how their drawings and with the relative positions are shown here. That is a assembly drawing type. Okay, in some parts for the manufacturing, this detail is required, like which element comes at where. So this is called assembly drawing. Now I will again back. In exploded, the parts are separately displayed, but they are aligned according to their assembly position and sequence. Here they are aligned with their assembly and positions. Second one, journal assembly drawing. All parts are drawn in their working position, means how they will be attached. I will discuss later. The third, all parts are drawn in their working position with a completed dimensions, in that is a detailed. So exploded is clear, all parts are exploded at some distance with their relative positions. Again, exploded assembly drawing. Okay, that is orthographic representation, mean one side is shown, first this element, then second this element, all the elements will be combined, then the piece will form. Journal assembly. Okay, here is a 3D view pictorial, orthographic projection. Okay, there is a cut, so the detail, which part will come at which position and which part will be connected to after which part. So all details are given in the journal assembly drawing. Again, this one, only dimension related to machine operation are given. Again, this one is also assembly drawing. Now part list, this is also called bill of material. Locate above or beside the title block, fill the table from the bottom, like number, part name, required material and not, like one material is spot, that is made of cast iron, second is shaft, stainless steel, set screws, stainless steel, that is the model of this set screw. Selection of necessary view, what it means, here you can see this one is the part A, means the same figure, that is you can say front view, that is right side view, that is the part B. So there are two options. Student A can assemble like this in this position, and student B like assembled in this position. So I hope you got the idea. That is a selection of necessary view. So I think this view is a good view or a good assembly drawing, that showing that this part as a whole will be connected through this cylindrical part. So I hope you got the idea. This one is the good one. General practice. Hidden lines usually omit unless they are absolutely necessary to illustrate some important features that reader might otherwise miss. So in journal, 99% we do not use hidden lines. Points to consider: surface finishing, tolerance, size, geometry. I have already discussed surface finish, like what type of finish or paint, etc. should be provided on the material surface. Tolerances in size and geometry, that is mentioned in the form of general tolerances or specific to the part. Surface finish. Surface finish means the quality of a surface. It relates to the level of roughness of surface. Purpose: to control the accuracy in positioning and tightness between matting parts, meaning the parts which are going to connect with each other, how their quality or the surface finish should be made. To reduce the friction, especially for the part moves relative to the other parts. Tolerance. Tolerance is the total amount dimension may vary. It is defined as the difference between the upper and lower limits. For example, to control an interchangeability of parts to ensure that matching part will have a desired fit. For example, if there is a machine part of 10-inch dia, so there is a tolerance that the dia with 10 inch plus 0.01 inch is okay. Or if there is 10 inch minus 0.01 inch, that dia can be go up or down, but that will be okay for the manufacturing sense. So that is called the terminology that is called tolerance. So that's all for today's lecture. Have a nice day.